This is problem 28 of chapter 7 of Giancoli's 6th edition. So what we have is a certain ball. They give us the mass of this ball, so I'll call it MA. And this ball is moving. It collides in an elastic head-on collision with a second ball that I'll call that has mass M, which is initially at rest. So we know ball A is moving, but we do not know its speed. The mass of ball A we know, but nothing is given about the mass of ball B. And we know that after this collision, the second ball moves off with half the original speed of the first ball. So after the collision, the speed of ball B is half of what ball A originally had, and we do not know about the speed of ball A. Okay, so the first question is, what is the mass of the second ball? So the first question is this: what is the mass of the second ball? How are we going to solve this? We know this is a elastic head-on collision, so I can play with two equations. I can play with the conservation of momentum, so MAVA plus MBVB equals to MAVA prime plus MBVB prime. We know that this equation comes from the action and reaction. And we can also play with this other equation, VA plus VA prime equals to VB plus VB prime. This equation comes from the fact that this collision is elastic head-on, so comes from the conservation of kinetic energy. Okay, so this equation comes from conservation of momentum, and the one below comes from conservation of kinetic energy in a head-on collision. All right, with these two equations, we are going to try to find the mass of the second ball. So if I start with the top equation, I see that it's not enough. I don't have enough information, right? I can write MA, which I have, but I do not have VA. VB, I know it's 0, so I don't need to write. On the right side, I have MA and VA prime, I do not know. MB is our unknown, and we do know that VB prime is VA over 2. Okay? So this is our unknown, but I do not have enough information to solve. So I'm going to get support from the second equation. And from the second equation, I can find out a relationship between VA prime and VA. Let's see how we do that. So we have VA prime we do not know, VB is 0, but we know that VB prime is VA over 2. So from here, we find that VA prime is minus VA over 2. So this is good. We can now use this back into this equation. So what do we get now? From this equation we have MA VA, so this is the equation for conservation momentum. MA VA is equal to MA. Now VA prime I'm going to substitute with VA over 2 minus VA over 2 plus MB and then VA over 2. So you see that VA appears in all the terms, so we can cancel it. VA, 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 and we will now be able to find MB. Right? We have here MA 1 plus half is equal to MB divided by 2. And from here now we can see that MB is equal to 3 times MA. MA is given to us, so we now know what is the mass of ball B. Okay, now the second question is, question B is, what is the fraction of the original kinetic energy? So the original kinetic energy is only the kinetic energy of ball A, that's the only one that is moving. So the original kinetic energy is just the one from ball A. So what fraction of the original kinetic energy gets transferred to the second ball? So the transfer to the second ball is delta K, meaning the final kinetic energy of ball B minus the initial. Okay? So what this question is actually asking us is what is the fraction of Ka that is transferred to B. So what they want us to compute is this ratio here. Okay? So Kb prime minus Kb divided by Ka. So this is the main problem, try to figure out what is it that the question is asking. And now we can continue. We know that the final kinetic energy is 1/2 of mb vb prime squared, and the initial is 0 because the initial is not moving. And the kinetic energy of ball A is 1/2 of ma va squared. Okay, these halves we can cancel, it appears up and down. MB we found before is 3ma, so you see that ma will also cancel. VB prime we know that it's half of VA, so I can put here VA divided by 2 squared, and at the bottom ma VA squared. So we see that the ma will cancel. We also see that the VA squared will also cancel. So we end up with just 3 divided by 4, and this is 0.75. So we found that fraction. Not all the kinetic energy of A is transferred to B, because if it was, we would have found 100%, but just a part, a big part actually, is transferred, 75%.